Morning. Can you all hear me? Thank you. Okay, I'd like to welcome you all to our second session of the UCG conference. And I just want to briefly introduce myself. My name is Dr. Zama Mjali. I'm from South Africa, Johannesburg. And I'm excited to be chairing the morning segment of this conference. And we're excited to have everybody join us for our final session. And we hope that you were able to be part of the incredible day one conference and that you were able to learn a lot from our speakers and that you had insightful conversations with our speakers. And those of you who still have questions that they would like to render, kindly do so via email. And our speakers would happily receive your questions and be able to answer them. And I would also want to appreciate Dr. Sophia and Dr. Naveen for doing a sterling job in chairing yesterday's session. And yesterday's session was quite interactive and informative. And we all learned a lot from each and every individual speaker that presented. And just a brief mention on what UCG conference is about. So the UCG offers a wide range of events, meeting, conferences, workshop, and symposium. We have a dedicated team who are aimed at acquiring the technologies, adopting the knowledge of business needs, and accelerate with best ideas and strategies. The UCG is a pioneer in the area of event management collaboration. We are a full service event provider specializing in the field of medical, clinical, healthcare, life sciences, environmental sciences for academic and industrial sectors. We stand out distinctively from our competitors for our commitment to quality, rounded and unmatched price, and we're able to provide you with the best event and meeting experience under one roof. We at the UCG conference make sure that you as a client choose the most appropriate event, and we thank you for finding the time in your busy schedules to be with us today. And today marks a major activity, existence of the UCG conference. And UCG 2022 is a remarkable event which brings together professors, researchers, and students in the field of breast pathology and cancer, making the online conference a perfect platform to share experience, foster collaborations across the industry and academia, and evaluate emerging technologies across the globe. We cordially invite you, or welcome you rather, to join us and witness the advances in this field together. The conference has attracted delegates who have come from all over the world, across the continents, and the subject of the conference is surely of global importance. The UCG thanks all the individuals and organizations who have worked to make the conference a grand success. UCG Program Committee has put in long hours with creative efforts. And finally, I would like to extend my appreciation to the participants of this conference, and we hope that you enjoy the conference and that our participation will contribute to our professional development and relationships. So I'm going to be introducing our speakers, and I just want to remind us all that the speech timing for our keynote speakers is 50 minutes, and the speech timing for speakers is 30 minutes, and the certification will be provided on the 14th of January, 2022. So welcome everybody, and please feel free to submit your questions as I've alluded before, and interact with us via the chat section or send your questions via emails. First and foremost, I want to introduce our keynote speaker of day 2 UCG conference, Dr. Anil Berger from Germany. Dr. Anil, if you could take the platform, please. He'll be sharing with us about the importance of deep integration on clinical routine diagnostics.
Okay, yeah, thank you for the kind introduction, and good morning, everyone. At least here in Germany, it's morning, and I'm honored to be granted a keynote speech here. My name is Anil Berger, a life scientist at heart and part of the management team of MindPeak. Let me start here. Okay, today I want to present to you the importance of a deep integration of AI tools into the clinical pathology workflow. And for this, I would like to structure our presentation into two parts. Firstly, the properties of the AI tools, and secondly, the deep integration part. Advances in deep learning and artificial intelligence are currently the hot topic in digital pathology, along with the trend to go fully digital. And there are substantial benefits that come with the use of AI tools. For a recapitulation, I have listed the most important ones here, but I would like to stress that it is even more important to choose the right AI tools in the first place. So classical computer vision and even many deep learning tools are not well or ideally suited for image recognition in pathology, which is a very special task for the AI models. So we set up a dedicated system for it with two main properties in mind. Firstly, the AI should work on a single cell basis to discriminate between tumor and non-tumor cells, for example, stroma cells, and then classify the tumor cells into positively and negatively stained ones, and give the respective clinical score per biomarker, for example, the DAPU score for HER2. Secondly, the AI should be able to cope with real-life image variability as a plug-and-play solution out of the box. We call it AI made in Germany. Our groundwork in the area of deep learning image analysis has been recognized by the German Institute for Norming, the DIN, I would say the most German institution there can be. And we even won a prize by the DIN at the end of last year for our efforts in the field of deep learning. And with this reputation, we were able to consult members of the German Parliament now on several occasions on the use of AI in healthcare. Our flagship product, Breast IHC, is a product suite, and Breast IHC contains quantifiers for three biomarkers, Ki67, ER, and PR in breast tissue, and fulfills the aforementioned properties, and also has a CE-IVD mark. Half a year ago, we also added the fourth biomarker to the panel, which is HER2. With this product suite Breast IHC, we performed the largest variability study to date for AI in digital pathology with a deep learning algorithm. And we used several common stainers and scanners, had then pathologists score the resulting whole slide images, first alone and later with the help of AI, always with a free choice of hotspots to make it really complicated, but suitable to real life. In this study, currently under publication in a peer-reviewed journal, we could show non-inferiority between both approaches. The result is at least as good when a human does it alone or when he does it together with the AI. And this is across stainers and across scanners for all biomarkers we investigated here. And I really would like to stress this as well. The first AI tool, a deep learning AI tool in digital pathology that is actually used in clinical routine in the US also comes from MindPeak, which we were able to announce by the beginning of this year. So a great way to start here. Bioreference Lab, a part of OPCO Health, has adapted our solution, and to make it really work, there was a deep integration of the AI into the PathFlow platform by Gestalt Diagnostics. Okay, I promised you some live demo, and here I will give a demo on the aspects I talked about earlier. Let me log on to our cloud solution. Okay, I have selected a case and I opened it. And then we can go for a file with Chi67, an image, maybe this one. Okay. And then we have in our viewer the usual functionalities that you have in an image viewer. You can see, for example, that the algorithm, the Chi67 algorithm, is automatically chosen by the identifier in the file name or slide name. And then I can zoom in, search for a nice area with infiltrating cells, maybe here. And then I press the right mouse button and circle an area, and I get instantaneously the result. You can choose another area, like here, for example, with a higher positivity. You see artifacts are ignored, and tumor cells are given as positive and negative tumor cells. The nice thing about this is that we can also choose larger areas. For example, we take a whole tumor here in an image, and the result is very quickly there. How is this possible? This is possible due to pre-calculation, which means the image has been processed directly after scanning. And then if we zoom in, we can draw one or many regions of interest. I can add some, and then the results are just uncovered because they are already in the image. And the pathologist, when he works with the case, will not perceive any time delay due to live computing. Okay, then I clear the results, and we can look for the discrimination between tumor and stroma. Let's maybe do it here. And as you can see, the tumor cells have been detected and classified into positively and negatively stained ones. Artifacts, staining artifacts are ignored, and also these spindle type fibroblasts, the stroma cells, are also excluded. Nice. Let's look at another area with a little more artifacts, like here. And you see also the staining artifacts are ignored, and we get a score. If we do not want several cells, for example, to be included, we can use an eraser tool and erase some of the cells. And then, of course, they are not longer considered in the countings. And if you want to adjust the type of a cell because you do not agree with the classification, positive or negative, you can simply click it and change the class. So it's important the pathologist always stays in full control. What I now showed you, this is our what we call demo IMS. It's a kind of viewer which launches our viewer and or an environment that launches our viewer AI console. And this is, as of last year, a CE-IVD mark tool for clinical routine diagnostics. Now we can have a look at the variability. So the image I just showed you is a good image. The staining quality is good. We have a nice contrast, nice background staining, etc. But I said it is very important that the AI works out of the box. So let's have a look at some other images that are not so ideal. And yeah. The second image here is a little trickier with more stroma in it. And let's try an area with stroma then. And you see the stromal cells are automatically excluded. And we can zoom in here and you see the nice discrimination. If you do not really agree with the distinguishing between positive and negative, and you would like to have some cells that are only slightly brown, always to be considered as positive, you can use this positivity threshold slider, and then more and more of these cells are detected that are comparable. But you can always go back to what the AI would propose initially. Then let's take another image. Here you see we have a little other color palette. It's a little trickier. The color intensity and brightness differ from the image before. There is also a kind of purple background staining, and the nuclear staining is also not optimal. But let's see. And here you see also the tumor cells are detected and classified correctly, instantaneously. Now let's take a picture that is a little wild. The part that is supposed to be white is actually brown. You can barely see any blue background staining, and thus the negative tumor cells are barely visible. Let's try the AI out here. And you see it still works quite well. Tumor cells are detected and classified correctly. And now I have often been asked the question, what kind of image is this? It's a very bad resolution, kind of monochrome. Many of you would probably consider it not suitable for clinical diagnosis, or at least borderline. But let's try our AI here. As you can see, even here, tumor cells are detected and categorized correctly. Yeah, and maybe as this is a hot topic for the moment, I would like to show you some PD-L1, which is a product that is currently in development and will come out very soon. This is non-small cell lung cancer, a biopsy taken, and yeah. What's important about the AI tool is that it not only gives you the TPS score, but it also considers the lymphocytes, and therefore it can give you also the CPS score. Here you see the classification, and the image quality, of course, for this image was quite good. This product will be launched within a month or two. And yeah, as you know, PD-L1 is a challenging one, as it is a membranous staining. And with the TPS and the CPS score, the pathologists really get everything they need. Okay, so much for that. Now I would like to come to part 2. I promised you to show you some live demonstrations about the integration of AI into different workflow platforms. In most cases, they are image management systems, so IMS. I've brought you 3 examples. And on these 3 examples, I'd like to, or even 4 examples, I would like to explain to you what distinguishes the type of integration from system to system. And you have already seen our viewer, the AI console in action. And of course, the integration is easier for the platforms if they just launch our AI console. This is possible with a click of a button. And this will be true for the first two examples. But the main difference then, and the benefit for the pathologist, comes when more and more integration is done, and it is a really deep integration into a platform via an API, an application programming interface, which is triggered by the IMS platform, and then simply sends the image data to our servers. They compute them and report the data back to be presented by the viewer of the image management system platform with which the pathologist is already used to work. Okay, now let's try the first one. This would be an application many of you know. Actually, I guess you know all of them. This is PathoZoom Digital Lab by Smart & Media. Maybe you will recognize the image. We have, or part of the image, we have seen it before. And what we can do now is we can zoom in and we can press the button AI analysis. By pressing this button, our AI console is launched. And then I can work here and circle an area by pressing the right mouse button and releasing it. And what you see here now is the live computing. So the image data is sent to our servers. We report from the highly parallelized cloud servers the results back, and they are displayed here. The result is no different because it's the same AI. And but this is, for example, for this type of integration, where the story ends for the integration. It's a, I would say, rather basic integration, but that's fine with us. The proliferation score is given, and also the counts for the different cell classes, positive and negative tumor for Ki-67 in this case. Yeah, you can choose one hotspot, you can choose additional hotspots, and then they are always combined, and you get the cell count, and based on the total cell count, the clinical score. Another integration I can show you is in Sectra. For this, I need to launch another browser, but that's fine. Just a sec. The system is loading. Sorry for the delay, but here it's not that simple to log on. But once you're logged on, you can work there easily. Could have prepared this, but didn't. I'm sorry. Anyway, this is a system that is quite common. And then I can go here. I can look for a suitable image, double click it. Okay, it's opened in the other. That's not good. How can I show you this? Let me try to share the other screen. I cannot drag it over, I'm afraid. Okay, let's try it like this. This should work. I'm really sorry for that. Here. Okay, we have an image in the Sectra viewer. This is the native viewer of Sectra. We can choose an area that is interesting for us, like here, and then we can press again a button that launches our viewer. We can choose the area that is of interest for us. We encircle it. We have now counted roughly 4,000 cells in just several seconds. We have classified them. The result is already the same that we had for the same image in the other views. And what is important, you can now press the button Submit Analysis Results, and then the results have been successfully submitted from our viewer to the Sectra system. And if we then go back, Sectra will store the results. And you can have one area, several areas. They will all be stored for later review. You have the results in your system, and you can further process them, for example, for a report. Now, let me switch again the view. Exactly. So if I open it again in the Sectra view, you can see that the area is stored like this. You can press the right mouse button on it. You get all the info from the region of interest, which staining it is, the score, the number of cells, and of course the location. You can have one area, many areas, and they are all stored. Now I switch the screens again. Another integration that has nicely played out, I explained to you earlier the first AI in clinical routine in the US thing was the collaboration with Gestalt that actually did a deep integration of our AI tools into their workflow environment. And if I start it, I quickly sign in. Okay, here I have the classical view of image management system. I have cases with different images in it. And let's take one that is, for example, this one. Now I go in this case to a Chi-67 image. I look for an area that's interesting for analysis. Maybe we take this one, and then I go to the menu that allows me to draw the region of interest. Okay, I chose the wrong slide actually. Let's take this one. This is also a nice implementation. So if I take the wrong slide, the system will automatically inform me about it, and I can do no wrong. So apply the wrong algorithm to the right case. Let's take then another case. Here we have the Chi-67. Okay, like here, we take an infiltrating area, choose the tool. We have a freehand tool, we have a rectangle tool, and we have a circle tool, whatever fits your needs best. This now takes also several seconds for the computing, and then the result is given. There it is. And what's nice about this implementation is usually in a breast cancer case, you not only have Chi-67, but you have the other biomarkers as well. And if you already performed them, you can quickly browse through the AI results by looking at the thumbnails of the images. So for example, the ER, you get the score. So it's an ER with high intensity with a proliferation of 90%. You get the number of cells that you have analyzed in their region of interest. The same for PR, for example. So ER positive, PR positive, which makes it a good outcome because it's good treatable, well treatable. We have HER2, the membranous staining. Let's have a look. So this is a HER2 positive, so also susceptible for Herceptin as treatment. And probably this way, you can easily come to the conclusion that the prognosis for this patient might be better due to well-treatable properties. Of course, you can always toggle the view here as well. You can show or hide the region of interest. This was the Chi-67, so ER, PR, HER2, and Chi-67. You can toggle the view. You get all the info about the area. You can use this for your report. And this way, you can work quite quickly. The system stores, of course, the regions of interest, the analysis, and this way you have a very effective workflow. Right. So, having shown you the first 3 examples, I also want to show you a very recent example where we made an integration that's Path Presenter. Let's look for a right case here. Let's take this one. Okay. Here we also have a Chi-67 image with infiltrating tumor cells. We can now then look for the Chi-67. This was a very small one. Let's take another. We save it. The annotation has been done. Now we need to wait several seconds and then the result will come as well. Okay. This was a user mistake. I'm sorry. Okay, as you can see, it's just performing the AI analysis. sends the image data to our servers. The result will come back soon, and then it can be reviewed. You have the distinguishing between positive and negative tumor cells. Even the non-tumor cells are shown here in this example. So there are different types of implementation of the AI, how it can be done in practice in the end. Okay. Coming back to my presentation. I think I hope to give you an overview of how AI can be implemented into digital workflows. Probably it's better for the pathologist the more it is integrated, the deeper it is integrated into the workflow, because then automations can be made, reporting can be assisted, etc. We have different ways of actually doing this. So our AI can be launched just in our by pressing a button in the platform, or we can have the deep integration where we simply get the image data, report the results per cell back, and the native viewer of the platform actually displays our results. Here it depends really on which is the leading system, the workflow system. In most cases, it is the IMS image management system, but sometimes it's also the LIS, the laboratory information system, that has the image data. Somehow the image data needs to reach our analysis servers, our GPU servers that can perform the analysis. And even if you have a very closed environment, where it's not easy to make an integration of third-party applitions such as AI, we can still circumvent this rigid or closed system. If we just get the image data, we can work with it, and then we can find a way of playing back the results into the workflow which you need to make an effective diagnosis. Here you see an excerpt of several platforms where we are already integrated or close to be integrated. And of course, this view will grow as there are many more platforms around, and what the laboratories actually use is quite diverse. Yeah, and with this, there is more potential for automation. If the AI is used in an IMS, images can be pre-calculated, which is already available. I have shown this to you. We had a whole biopsy that we encircled, and the results were displayed immediately with no time delay. This can be done if the AI servers get the image data directly after scan, so before the pathologist actually works on the case. Then the results are hidden per cell. And if one or many regions of interest, irrespective of how large they are drawn, then the results are simply uncovered and not calculated. What we will also offer quite soon is an automated hotspot recognition. I mean, we can distinguish between positive or between tumor cells and non-tumor cells. And if we then apply the basic routines that pathologists use in terms of size, how large an area needs to be to qualify as a hotspot, for example, we can program this into the system, and then we will have an automatic tissue segmentation, which will then make it easier for the pathologists, because they don't have to draw anything. They just have to review the proposed hotspots by the system, and they will get a score for the whole slide image directly when they open the case and the slide. And of course, they will get an information where to look with focus, because the highest proliferation will be found in a certain hotspot, if there are many hotspots. Yeah, we can, of course, have additional stainings. So if a clinical score, for example, triggers the order of an additional staining, let's think about HER2. And in many cases, when it's a score 2, there will be done an ISH analysis, SISH or FISH. This could also be triggered automatically if there is a nice connection between AI, IMS, and LIS. But this requires some integration. What we have heard is that it's in the end worth it, because the time until this SISH or FISH result then is available is shortened significantly. And of course, if the results are in the system, they can be used for downstream applications, for example, report generation, where appropriate text blocks can be chosen and compiled into a report. For one staining, for the combination of several stainings, if you think, for example, of ER, PR, and HER2 as probably markers for the or as markers for the triple negative breast cancer with a very bad outcome, it might be a solution to also have a shortened reporting time. Yeah, and so in summary, there are several aspects of the AI which the AI itself needs to bring from a pathologist perspective. It should work on a single cell level, because this is how pathologists in many cases work. It should be robust enough to work with real-life image variability out of the box, so that there is no adjustment needed from lab to lab. And this way, the AI automatically considers the required cell classes and gives the respective clinical score, which is applicable for the for a certain biomarker. If we then have a deep integration, the full potential of AI in the digital pathology workflow is unlocked. The time to diagnosis is sped up significantly, for example, with image pre-processing directly after scanning, and even further with the availability of automated hotspot recognition. For a seamless user experience, all AI functions are available directly in the IMS viewer, for example, a side-by-side view, different stains, and even maybe some dedicated tools, such as the one that would be needed for the new international Chi-67 in breast cancer working group guideline that is first adopted by Sweden beginning of this year, where 4 hotspots need to be chosen on a whole slide image, and the whole image needs to be considered rather than one hotspot. And there is a weighting between the 4 hotspots to come with a weighted, come up with a weighted Chi-67 score. So if you were to do it alone by hand, it would dramatically increase the turnaround time per case. If you have an AI tool and a user interface that allows you to do the necessary things in a very quick fashion, you can, of course, save the time that would otherwise hinder you. In addition, pathologists need to be in full control. So they are the ones signing off the report, and they should be able to override the automated analysis if necessary. They can change classes of the cells, remove larger areas, or adjust, for example, the threshold to their personal view, or, for example, group view. We have also realized that there are different interpretations about, for example, Chi-67 stainings, what is considered a positive cell and a negative cell. This might differ between labs, but also it might differ between countries where there are actually guidelines with images as example. So this can be adjusted, of course, this can be hardwired, but in any case, the pathologist stays in full control. Yeah, and lastly, the deep integration into a whole software environment can improve lab efficiency significantly, by automatically triggering additional stainings or by preparing reports with text blocks. And in the end, with having reproducible scores for all slides and cases, it makes it even possible to mine for new cutoffs, for example, when correlated with treatments and clinical outcomes. Yeah, not every lab can, of course, afford to go fully digital because this entails significant investments. So I would like to stress that actually any lab can benefit from AI. Of course, we can help you make the most of the AI capabilities depending on the degree of digitization of your lab. And for this, I also want to show you something. So until now, I have showed you the deep integrations of AI, but we also have a web-based solution where you can simply copy-paste an image or drag and drop an image, upload an image. You just put the image into it, and you draw a region of interest, and it is calculated. This can be used by actually anybody who has some kind of digital image, even without scanners, for example, with a camera that is attached to a microscope. All our algorithms are available here. And so Ki-67, ER, PR, HER2, and very soon also PD-L1 for non-small cell lung cancer. Maybe just here an outlook. Our PD-L1 scoring tool will first of all cover the stainings with SP263 by Roche, and later on additional antibody clones. As you might know, the staining results differ quite a lot between antibody clones for this biomarker. So probably we will have different algorithms for different antibody clones. Okay. Yeah, with this, I would like to take the opportunity to thank you for your patience and of course our team of experts and for example data scientists and developers, and of course our integration partners that I were able to showcase today. Thank you very much for your